Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. This is the last part. Okay, 13th part. Till now I have given 12 parts. This is the 13th part, last part. So only one last concept, that is the potentiometer. Okay, what is the potentiometer? What is the potentiometer? This one also question is completely practical question only for PU purpose. So the derivation, all those things won't come. So just for problems purpose only, very important. Problems purpose very important. Okay, so one formula will be there. E1 by E2 is equal to L1 by L2. Okay, comparison of EMF of a cell. Right, this is the one of the most important question. Right, E1 by E2 is equal to L1 by L2. Right, so what is the potentiometer? Potentiometer is the instrument which is used to find the internal resistance of a given cell. First one, what is that? Internal resistance of a given cell. First point. Second point is which is used to find the EMF of a cell. EMF of a cell. Next, third point. So which is used to comparison between two EMF of cells. Okay, so comparison of EMF of a given cells. Okay, so that is like that we are having three questions. And first one is, what is that? So internal resistance of a cell. Second one is EMF of a cell. Third one is comparison of a EMF of cells. Comparison of EMF of two cells is a very important. So two questions we will do in the practical only. One is internal resistance of cell and a comparison of cell. These two questions are practical questions. Right, okay, what is a potentiometer, what is the principle, all those things I will give you right now. Okay, potentiometer is nothing but a potentiometer is an instrument used for measuring an EMF of a cell. A potentiometer is an instrument used for measuring an EMF of a cell or potential difference between 2 points. Potential difference between 2 points in an electrical circuit. Right, what is that? The potential difference between 2 points in an electrical circuit. That is nothing but potentiometer. A potentiometer is an instrument which is used to measuring the EMF of a cell or potential difference between 2 points is known as potentiometer. Right. With the help of a circuit diagram, this is the one question. What is that? With the help of a circuit diagram, explain the principle of potentiometer. Right, definition I have given. Next, again here one question I have given. What is that? With the help of a circuit diagram, explain the principle of a potentiometer. With the help of a diagram, explain the principle of potentiometer. Alright, so what is the principle of potentiometer? Principle of potentiometer is nothing but if a wire of uniform area of cross section, if a wire of uniform area, this word important, the wire is having uniform cross section, uniform area of cross section carrying steady current, constant current also, it can maintain constant current. Remember, current is constant, carrying a steady current, then fall of potential across any portion is a series combination completely. Therefore, potential difference is different at different points. Okay, so potential across any portion of the wire is directly proportional to the length of the portion. The length can increase, mean the EMF also can increase. The length can increase, mean the potential across any portion also can increase. That means show that V is proportional to L. That is the question. Show that V is proportional to L. Right. So this is the our potentiometer diagram. As a potentiometer diagram, this is the battery. This is the rheostat. Right. rheostat. With help of rheostat we have to change the voltage, right? Okay, next is the battery voltage V, and here this is the wire. This is a uniform wire, very long wire, nearly we will consider in the experiment 400 meter, 4 meters, 400 centimeters wide, that is 400 centimeters wide, that is A to B. We have to arrange in the between A to B. So for centimeters, this is the A, here one strip, again here another strip, so again here another strip, like that we have to arrange the potentiometer wire. This is the A and this is the B. So now here battery, like that we have to arrange the battery in this manner will be there. Okay, so like that will be there. That is the potentiometer arrangement, right? Very important experiment also. Okay, the resistance capital R of a length of L. So from here to here I will consider portion. Now this is the my portion, selecting portion. The total length is equal to capital L. Total length is equal to capital L. Total length nearly 400 centimeters. That is the length of potentiometer, wire length. Okay, now portion. At that point, we are finding the null deflection. We are finding null deflection. This is a galvanometer. So galvanometer will show null deflection. So at that point, length is equal to L, small l. That means resistance per unit length. Resistance per unit length. Okay, na? So resistance R for a length of the wire is R is equal to formula. What is that? R is equal to rho into L by A. Equation number 1. So now current is flowing right here. In this direction current is flowing. So that V is equal to IR. I want to potential difference. Potential difference I want. Therefore V is equal to, so V is equal to I into R formula, okay, I only. R is equal to rho into L by A. Now I into rho into A. This is having uniform area of cross section. A is the constant. Current I is the steady current. So resistivity same wire only na. The wire is having same resistivity. Therefore I rho A is the constant. I rho A is the constant into L. So this constant we will consider as a phi or K. Phi or K. So that V is equal to phi into L. Where phi is equal to constant, we can call it, that is the potential gradient. Potential gradient is nothing but the potential per unit length. The potential per unit length. The potential per unit length is known as potential gradient. The potential per unit length is nothing but potential gradient. Alright, okay. So V is proportional to L. Correct or not? The length is more mean the potential drop also more. The potential difference also more. That is the principle of potentiometer. Now next second question is, so give the expression for EMF of a cell with the help of potentiometer. Right. So first question is the first question. What is the first question I told previous? So what is with help of potentiometer easily we can calculate EMF of a cell. For this purpose, this experiment. Okay, same arrangement. What is that? This is the battery, this is the rheostat. Okay, RS. Okay, so this wire also having resistance. Remember, this wire also having resistance R. The total length of wire is equal to L. Okay, here I arranged here one of a EM cell. This cell EMF is equal to E. Remember, in a potentiometer here negative means here also negative only required. So negative only required. If you put here positive terminal mean, so the such type potentiometer does not work. Okay, that is impossible. Such type of potentiometer not arranged. Okay, na? So not there. That's it. So always here minus mean here also minus, here positive mean here also we have to consider positive only. Correct or no more confusion? So then here potential that means here potential drop here potential gradient is equal, I took there x only. Okay, at this point, galvanometer shows deflection, shows zero deflection. Galvanometer shows zero deflection at this point C, that is the C. Okay, so now we can observe here, this is the zero potential, here V potential, so will come 0 0 according to free vessels, we don't know. So 0 0 at point E also 0. Similarly at point V, here V, so that will come here at point B also V potential. V potential, are you clear? V potential. For example here, so there is no resistor, mean V potential only will come. So here resistance will be there, mean different will come. Correct? Huh? So there is no resistor right now. Right now there is no resistor. So that here total potential is equal to same only will come. Same potential only will come up to here. Correct? Huh? This battery is given. Right. So now at this point the current is flowing in this direction. But here the current in galvanometer showing zero deflection. That means in this direction current is not flowing. Current is not flowing. Why is that not flowing? Current is not flowing means zero deflection. Why not? Zero deflection is happening. You know. What is the reason? That means at point C, at point Y, both are having same potential. At point C, at point E, potential is equal to same. In that case, what would be happen? So the current cannot flow in this direction. In this direction, I is equal to 0. Ig is equal to galvanometer current is equal to 0. Understood? Why 0? That means at point C, at point E, the potential is equal to same. How much potential here, sir? Here, how much potential should be there? That much only. Correct? Here is the internal resistance. Is a cell in R is smaller is the internal resistance of a given cell only. So that here EMF, here 0, here also 0, right? So this is the E only. Na? So therefore here also how much will come? E only. Correct? That means here 0, here also 0. Here E mean here also E only. Na? That means so potential difference between AC. So delta VAC is equal to delta VXY. Correct only, right? Yes or no? That is the most important form. Then delta VAC is equal to how much? Delta VAC is equal to how much? That is that proportion. This you can observe here. What is that? So potential is directly proportional to L only. Na? Therefore, the total length of wire is equal to L. Potential is equal to V. So L you can transfer. That means what happened? So 1 is equal to V by L. If I take here x meters mean x is equal to x meters mean V by L into x will come. 1 mean V by L into 1. X mean V by L into x. This is the potential drop. V by L into x. That means the potential drop between A and C. VAC is equal to delta VAC is equal to V by L into x. This is the very, very important formula. Remember always. So delta VAC is equal to V by L into x. V by L is what? Potential drop per unit to length. Potential drop per length is nothing. Potential gradient only. Na? Potential gradient we can represent as a phi only. So potential is directly proportional to L only, right? X only. Na? X mean here L. Previous I took there small L. Now I took there X, so no more confusion. Previous I took there L, small L, but right now I took there small x only. So that V is proportional to L. Same formula, right? So that's what this formula you have to remember always. This is the most important formula. So instead of delta VAC, we will consider V by L into x. Delta Vxy, that means here potential is equal to how much here potential? So E minus 0 mean E only, na? So that is equal to E. So with the help of this formula easily we can calculate Emf of a cell. That E is equal to V by L into x. X value also we know. V value battery voltage potential. So L is equal to length of a wire. Length of a wire in potentiometer. So with the help of this one, we can easily find it E value, right? That's it. This is the formula. Very, very important formula. E is equal to V by L into x. V by L into x. Are you clear? So one more also small formula will be there. That is, you can remember, so V is equal to I into R. Previous I have given, right? Previous I have given. So here, for example, resistor will be there. This resistance is equal to RS. Okay, so I is equal to formula what? I is equal to, is a special formula, different formula. I is equal to E by R plus resistance is equal to R. The Y resistance is equal to R. So rheostat resistance is equal to RS into R. R is equal to what? R is equal to rho into L by A only, na? L by A. Correct? This L you can transfer that side. Therefore, what would be happen? V by L is equal to E divided by R plus RS plus small r into rho by A. Rho by A. Rho by A, I can write it formula R is equal to rho into L by A. So, total length this one. R is rho into L by A. So, now rho by A, what we can write? R by L. Correct? R by L. Therefore, finally I will give one special formula. This is the, what is V by L? Potential gradient. Potential gradient is equal to E by R plus RS plus R into rho by L is nothing, rho by A is nothing but R by L. This is the one of the most important formula for solving problems purpose. V by L, potential gradient, this is potential gradient is equal to L mean what is the small L? Small L mean this one only. Okay, capital mean total length of potentiometer wire. So R, what is R here? Resistance of a potentiometer wire. RS is equal to resistance, this series resistance. R is equal to internal resistance of a cell. R by L. L is equal to length of a wire. Length of a wire. Most important formula this one. Remember everybody. Right. Now based on that, this formula, we will solve one problem. One or two problems we will solve now. Okay. So problem number 1. I have given there. So what is that? Here potential. This potential is equal to V is equal to 48 volt I have given. Here resistance will be, that resistance is equal to 2 ohms. And length of potential wire is equal to 10 meters. And balancing length is equal to what? Balancing length, null point here shows null point, 0 deflection. So from here to here is equal to X is equal to how much? Balancing length is equal to how much? And here EMF of a cell is equal to 12 volt is given. Internal resistance is equal to 1 ohm is given. Okay. Then what is the X value? Find X value if E is equal to 12 volt. Wire has resistance is 10 ohms. This wire is having resistance is equal to how much? 10 ohms. Remember, 10 ohms. Then this is the 10 ohms and also here 2 ohms will be there. Total series combination only. Now this one you can leave it. This is not required. Current can flow like that only. Current cannot flow this direction. Why? Because so here potential, here both are same only. Na? So that's why that is a null deflection, right? Therefore, we want to consider total resistance. This one is a metal strips. That is metal strips also having some resistance. So this here one resistor will be there. That resistor is equal to 2 ohms. This wire is equal to 10 ohms. Total resistance is equal to 10. 2 plus 12 is equal to 12. Therefore, R equivalent is equal to 2 plus 10 is equal to 12. Potential, how much is the potential difference? V is equal to 48 volt is given. Then current is equal to how much? How much current can flow in this direction? I is equal to what? So I is equal to formula V by R. Correct only na? Therefore, V is equal to 48. R is equal to 12. That is equal to 4 amperes. Why sir this is required mean? So they are asking X only. What is the meaning of V? Here potential. Here potential how much will be there? 48 will be there. But potential 48 will come here at point B. Also the potential, is it 48? No. Why? Because here resistor will be there. That means at this resistor some potential can drop. Some potential can drop only, right? That's what here some potential will be there. That potential First, we want to calculate I value. Correct? So I is equal to 4 amperes. Now potential drop at 2 ohm resistance is. I took the V dash. V dash is equal to I into R. Formula. I into I is how much? 4 amperes. And R, this R is equal to how much? 2 ohms. So 4 into 2, 8 volts. Correct? That means at this point potential can drop how much? To 8 volt. 8 volt can drop there only. Remaining potential will go here. How much remaining? So 48 minus 8 only. That is why next point I have given potential at point B is V double dash. I have given that. See, V double dash is equal to 48 minus 8 is equal to 40 volts. That is the answer. Correct? Now X is equal to what? So formula, what is the formula? V by L, mean V double dash by L. L is equal to, you can take capital L also, no problem. Okay, into X is equal to E. V double dash is equal to 40. Capital L is equal to, how much is given? Capital L is equal to, so 10 meters into X is equal to E value, how much is given? 12 volt. So 0 get cancelled, 4 ones, 4 threes. Therefore X is equal to 3 meters. Are you clear? So one more small problem we will do. Right. So problem number 2 I have given like that. What is that? So here battery voltage is equal to 40 volt and here resistance is 6 ohms and the length of wire is equal to 10 meters. Okay. Then on wire, this wire resistance is equal to 4 ohms I have given and EMF of cell is equal to 24 volt I have given. Yes or no? Then find the X. X is equal to how much? So here 6 ohms will be there. The wire is having so 4 ohms. Therefore R equal is equal to 6 plus 4 is equal to 10 ohms. Then I is equal to what? Then I is equal to what? I is equal to V by R only, right? V is equal to 40, R is equal to 10. Therefore 4 amperes will come. Then at 6 ohms potential is equal to how much? Potential is equal to how much? That is why potential at 6 ohm resistor is V dash is equal to V dash is equal to I into R. I is equal to 4, R is equal to 6, therefore 24 volt will come. Then remaining, then potential at B is V double dash is equal to total potential is a 40 and EMF is equal, this V dash is equal to 24. So 40 minus 24 is 16 volt will come. Then X is equal to what? Therefore X is equal to formula V double dash L into X is equal to E. So V double dash is equal to how much? 16 by L is equal to 10 meters is equal to X into X is equal to E value how much? 24. Correct? Then X is equal to 24 into 10 divided by 16. So 4 4 is 16. Then 4 6 is 24 and 2 2 is 4 and 2 3 is 6. Okay, and 2 5 is 10. So 3 into 5, 15 meters. That means null point where came from? At 15 meters only. But wire is given how much? 10 meters. Is it possible? Not possible. That is why answer is what? With the help of 10 meter wire, this is not possible. That is answer. Right? Okay. Next topic is so comparison of EMF of cells. Right. So next question is comparison of EMF of a two cell. EMF of two cells. Okay, two cells are there. So first cell is equal to EMF is equal to E1, second cell EMF is equal to E2. So we have to arrange as shown in the figure. Okay, this is the battery voltage. Remember, battery voltage always greater than of EMF of cells. Okay, EMF of cells always less than of EMF of a battery. And also polarity is not a so reverse, opposite. Polarity same will be there. That is the conditions you can remember. Okay, in a potentiometer. Okay, so first one I want to E1. I want to compare E1 by E2 is equal to L1 by L2. That is the formula I want now. Okay, so first one. What is the first one? First one is so close the. We want to close first case one. This one. Case 1 direct. So what is the case 1? For case 1 purpose, first K1 cell K1 cell, E1 cell key K1, E2 cell key K2. K1 is closed and K2 is open. In that time we want to consider EMF of your first cell. Second time is K1 is open, K2 is closed. In that time we will consider EMF of second cell. Okay. Now first one is I want to case one EMF of first cell. EMF of first cell. That is my question. Okay. So now I can close this one. Yes, K1 is closed. K1 is closed. Now galvanometer. So showing reflection somewhere here. So for example here C, this is the J1. This is the J1. For example here J1 is happened. This is the C, is the J1. So from here to here I will consider X1 X is equal to L1. Okay, L1. So according to formula, you know what is the formula? Your potential is equal to how much? V only. There is no resistor. Resistor is there, means so potential should be changes only. So now there is no resistor, only wire only. So that according to formula, what is that? So V by L into X is equal to E1. Correct? Therefore V is equal to V only. And this is the total length is equal to small l or capital, no problem. This is the L1 is equal to E1, equation number 1. Now case 2. Case 2 is nothing but, what is that case 2? So when now K2 is closed and K1 is open. In this case, what is that? So K1 is closed and K2 is open in this case. So now K1 is closed, K2 is K1 is open, K2 is closed. Now EMF is equal to E2. Correct? Therefore formula V by L into X2. I will cut, this is the X1 or so X1. Okay, is equal to E2. That means again we have to do null deflection. Again null deflection we want to consider like that. So somewhere here will come, what is that null deflection? So from here to here, what is that? X2 is equal to L2. X2 is equal to L2. Correct? Here I got null deflection. Null deflection. So formula again, what is that? So V by L is E into X2 is equal to how much? L2 is equal to E2. Equation number 2. Now we will do 1 divided by 2. First equation, what is that? V by L into L1 is equal to E1 divided by E2. So divided by V by L into L2. So we cancel. Correct? Therefore L1 by L2 is equal to E1 by E2. Very, very, very important formula. Or else E1 by E2 is equal to L1 by L2. That's it, ma. This is the comparison of EMF of cell. In the question problems point of view, they will give you E1, E2, L1. They will ask L2. Or else L1, L2, E2 they will give you. They will ask E1 only. Right? One problem we will do. Right. Right. So NCERT textbook problem. This is exercise 3.12. 3.12 problem. This is. So in a potentiometer arrangement, a cell of EMF is 1.25 volts, gives a balance point at 35 centimeters. E1 cell is given, balance point, null point is at 35 centimeters. Length of a wire, if the cell is replaced by another cell and the balance point shifts to 63 centimeters, then what is the EMF of the second cell? What is the EMF of the second cell? Right. So E1 is equal to 1.25 volt is given, L1 is 35 centimeters is given, L2 is equal to 60 centimeters, E2 is equal to what? Therefore formula you know. So what is that? E1 by E2 is equal to, so L1 by L2, right? I want to E2. Therefore E2 is equal to E1 into L2 by L1. Correct? And then substitute values. So E2 is equal to, E1 is equal to 1.25 into L2 63, L1 35. Do calculation. So if you do calculation, you will get answer 2.25 will come. 2.25 volt. Centimeter can cancel. So that if you do calculation, you will get answer 2.25 volts. Right? This is the comparison of two cells. Is the finish. Now next third question is, what is the internal resistance of a cell? Internal resistance of a cell. Right? Okay. Right. So next now, last question in the potentiometer. What is that? Determination of internal resistance of a cell. We want to find it internal resistance of cell. This one, right? Resistance. Then what is the process? Right. First process is, so first we want to close K1. That is the case 1 now. Same as usual. Case 1. What is the case 1? K1 is closed. K2 is open. K2 is open. Okay. K1 is closed. K2 is open. K1 is closed. K2 is open. In that case, we want to calculate. So, is the null deflection C? Okay, that is the J1. J. Right? J1 or else. From here to here, I will consider L1 distance. Total length is equal to L. Right? EMF is equal to E. Therefore, potential is equal to V. So that according to formula, what is that? So, V by L into L1 is equal to E. Correct? Equation number 1. This is equation number 1. Are you clear? E is equal to V by L into L1. That is the case 1. Next, case 2. Case 2 is now K1 as well as K2 is closed. Both are closed. So both are closed. Now what happened here? Again, so null deflection will come somewhere here. This is the C dash. So from here to here, I will consider L2. Here to there, I will consider L2. Now in that case, so cell is open mean, yes, a circuit is open mean, that is the EMF. But circuit is completely closed. Now this is not a EMF. What is that? Terminal potential difference. Correct? That means at this point potential is equal to E minus I into R. Correct, Melinda? So this one we want to separate here. Potential is equal to how much will come? V is equal to E minus I. That means terminal potential difference. K1, K2 both are closed. Then terminal potential difference is, so now same formula. What is that? V by L into L2. Instead of EMF, what will come? Terminal potential difference. What is that? E minus I into R. Terminal potential difference with that one on the formula. Did you remember or not? Yes. So this is the equation number 2. So now we will do equation 1 divided by equation number 2. So E by E minus I into R is equal to V by L into L1 divided by V by L into L2. So this one get cancelled. So that what came from here? L1 by L2 came from. Correct? So now instead of I, formula, instead of I is equal to E divided by R plus small r only. Here capital R is equal to resistance of a wire. Small r is equal to internal resistance of a cell only. Therefore, minus I is equal to E divided by R plus small r into small r. Alright? Is equal to L1 by L2. So now, what is the common here? So, common is equal to, now you can do this one. What is that? So, common is the E get cancelled. R plus L goes to numerator. As an R plus R. So, here E get cancelled. This one LCM is equal to how much? R plus R minus R is equal to L1 by L2. Correct or not? This one get cancelled. Therefore, what will come here? So, now R plus small r divided by capital R is equal to L1 by L2 will come. L1 by L2. Correct? This one we have to observe. This is 1 plus R plus R. Any objection? R get cancelled, 1 will come. Is equal to L1 by L2. Okay, now this one transfer that side. Therefore, R by R is equal to L1 by L2 minus 1. Therefore, I want to small r, right? Small r is equal to R into L1 by L2 minus 1. This is the internal resistance of a cell. Internal resistance of a cell. Small r is equal to R into L1 minus L2 by L2, L1 by L2 minus 1. Or else R is equal to R into L1 minus L2 divided by L2. Divided by L2. This is the internal resistance formula. Very, very, very important to finding internal resistance purpose. Alright? Is the information about potentiometer. Potentiometer is a finish. Okay. So when we will say the potentiometer is more sensitivity. Potentiometer is more sensitivity. When we will say, so if we measure very small potential difference, in that time we will say this is the very sensitivity, like that. Sensitive potentiometer is the very sensitive potentiometer. Correct? That's why sensitivity of a potentiometer is, so what is that? Potential gradient V by L is inversely proportional to the potential gradient. Right? This is the formula also, remember here. So S is proportional to L by V. What is that? Sensitivity of potentiometer. Are you clear? This is the concept of potentiometer. Sensitivity of potentiometer. That's it. Right, ma? So this is the current electricity. So much of information I have given. Total 13 parts will be there. Okay, based on that also problems you have to practice it. Alright, clear, you can listen again. Alright, okay, thank you to one and all. Thank you.